All right, in this video, I'm going to be working problems 14 through 26 on the study guide. So I'm going to begin by working problem number 14. You can hopefully see it there on study guide B. And it says the perimeter of the rectangle is 30 centimeters. Find the value of x. Okay, so the perimeter is equal to 30, and it wants us to find the value of x. But if you look at the bottom, there's a picture, and it has this with the picture, 6 and 3x. Okay, so those are the two links, the two side links of this rectangle right here, and what it's telling us is that the perimeter is equal to 30. Now, if you remember how to find the perimeter of a rectangle, the way you find the perimeter of a rectangle, or any shape for that matter, is you take all of the side links and add them together. So for this one, if I was going to add all the side links together, I would need to know this bottom side length right here. And since the top is 6, that means this bottom is 6 as well. And since this side is directly opposite of that side, and this one's 3x, it means that the side over here to the left is 3x. So these are all of the side links that I have. And so I'm going to add those together. The way you find perimeters, you add all of the side links together. So that'll be 6 plus 6 plus this 3x, and then plus this 6, and then plus this 3x. Okay? And that's equal to the perimeter. But here's the key, is that they told us the perimeter is 30, right? It is 30. So those things right there, the 6 plus the 3x plus the 6, and this right here should be a 3x. I accidentally wrote a 30 there, but it should be a 3x, right? Those things added together are the perimeter, and the perimeter is 30, so these two things should be equal to one another, right? Adding them all together is how we find the perimeter, and they've already told us that the perimeter is 30. So this is the perimeter, and that's the perimeter. So since they're the same thing, they should be equal to one another. And so now what I really want to do is I want to find the value of x, right? That's the final step of the instructions there. Say find the value of x. And so this is just an equation that I need to solve. So got my equal sign that's really splitting this thing in half. And in this problem, I got some like terms to combine over here on the left side. There's a 3x and a 3x, right? And so a 3x and 3 more x gives me 6x. And then I have a plus 6 and a 6. So 6 plus 6, since those are like terms, are going to give me 12. Should be equal to 30. All right, and now what I'm going to do is I'm going to try to get this x by itself. And just like I've been doing in the past, in order to do that, I need to get rid of this 12 first. So I'm going to do the opposite of adding 12, which is to subtract 12 from both sides of the equation. So these cancel, and 6x is equal to, and 30 minus 12 is 18. And now, to get x by itself, I'm going to divide by 6 on both sides. So x is equal to 3 in this case. Right? So it took a couple of steps. I had to take my perimeter and add the pieces together to get the whole thing and set it equal to 30. So all of my pieces added together here give me that 30. And then it's just an equation to solve. So I combine like terms. Then I subtracted 12 from both sides, divide by 6 on both sides, and we find that x is equal to 3. All right, look at number 15. Number 15 says, find the unit rate for the number of parts manufactured per hour if 1,042 parts are made in 6 hours. So we have 1,042 parts made in 6 hours. And we want to set this thing up like a proportion. Okay? And so we set it up like a proportion. 10,042 parts per 6 hours, but this wants a unit rate. And so if you remember, the special thing about a unit rate is it's over 1. Okay? Over 1. So if that's the case, you want to know how many parts are made in 1 hour. So all we got to do, this is a really simple problem. We just take our 1,042 and divide it by the 6 on bottom. We really just do what this says. 1,042 divided by 6. Right, so 1,042 divided by 6 gives us 73.66666 repeating, right? And it says to round to the nearest integer, right? Round to the nearest integer. Okay, that's an important vocabulary word. And if you remember, integers are positive and negative whole numbers. So things like -2, -1, 0, 1, 2, 3. Those are integers, but integers have to be whole numbers. So in essence, this thing is telling me to round to the nearest whole number. Okay, and so if I have 73, it gave me 173.66 repeating. So I'm going to round to the nearest whole number. So that would be this spot here. So this is actually going to be 174. So this is 174 parts per hour is the unit rate. All right, let's look at number 16. 16 says a 24-ounce bottle of water cost $1.68. What is the price per ounce, right? What is the cost per ounce? So 24 ounces cost $1.68, and they want price per ounce. So price per ounce should look like this: price on top, per, and then the ounce on bottom. Okay, so that means what I have right here is backwards. Okay, so let me flip this. It's going to be price 168 per 24 ounces. And we want to know the cost for 1 ounce. Remember, that's a unit rate. So all we really need to do is just divide this again. So I'm going to do 1.68 divided by 24. And that gives me 0.07. Okay, and if you remember, we had dollars on top, so that's price per ounce. Right? Price per ounce. All right, let's go to number 17. It says write the conversion factor for seconds to minutes. Use the factor to convert 135 seconds to minutes. Well, the conversion factor is just this. It's the relationship between seconds and minutes. And so we would say that 60 seconds is equal to 1 minute. That's our conversion factor that we're going to need to use. Now, it wants us to use that to convert 135 seconds into minutes. So this is what we have, is just 135 seconds, and we want to change it into minutes. So this is a simple problem. I'm just going to put this over 1, right? So 135 seconds over 1. And now remember, we need to put these in some order. One of them's got to go on top, and one of them's got to go on bottom. So I have two options. I can put 60 seconds on top and 1 minute on bottom, or I can trade them. I can put the 1 minute on top and the 60 seconds on bottom. Well, here's what I'm really going to look at. Since this first part right here has seconds, right? This is in terms of seconds. And I'm trying to get rid of seconds so that I can get minutes. What I'm going to do is I'm going to put this one in the place that will actually get rid of my seconds. And you can see these seconds right here on top in this first problem. So what I'm going to do is I'm going to put mine on bottom. So I'm not going to put them on top, I'm going to put them on bottom, so that now I have one set of seconds on top and one set on bottom, so I can cancel them out. And so if my 60 seconds went on bottom, that means my 1 minute needs to go on top. And so now that my seconds are gone, you can see the only unit left is minutes. So whatever my answer is going to be in minutes. And remember, all you have to do is multiply everything on top together. So I'm going to do 135 times 1, right? I'm just multiplying those together. And 135 times 1 is 135 minutes, because we had minutes on top. And on bottom, I have 1 times 60. So 1 times 60 makes 60. And there's no unit anymore because these seconds went away. And so now this is just a simple division problem. So I'm going to do 135 divided by 60. Enter. And what I get is 2.25 minutes. So that's our final answer, just the 2.25 minutes. Okay, let's go to number 18. 18 says this: a car is driving at a speed of 65 miles per hour. So that's per 1 hour. what is the speed of the car in feet per second? So here's what they've done. They've given us miles per hour, and they want us to change this into feet per minute. Okay, so feet per minute. I think I said seconds earlier. It's minute. What is the speed of the car in feet per minute? So right now we have miles on top and hours on bottom, and they want us to get to feet per minute. So we actually have two things that we have to do here. We have to change these 65 miles. Those are going to have to be changed into feet. And our 1 hour is going to have to get changed into minutes. And you can choose to change whichever one of them you want to first. You can change either of them first. So you just pick which one you want to change first and change it, and then change the other one, and you'll be perfectly fine. This is just a random choice. And so I'm actually going to choose to change the hours first. So these hours that are on bottom, I want to change into minutes. Now the relationship I know is that 1 hour is equal to 60 minutes. So these are my choices. I have 1 hour and I have 60 minutes. And remember, I can put either of them on top or bottom. And so the question is, where do I want these to go? Well, here's what I'm looking at. I have hours on bottom already. So that's going to tell me where to put my hours, because if I already have hours on bottom and I want them to cancel, I need to put this one in the opposite space. I'm going to put the hours on top so that my hour on bottom and my hour on top cancels, and I won't have hours in my problem anymore because I just want minutes left in my problem. And now because the hours are on top, the 60 minutes just has to go on bottom, just kind of by default, right? There's the only one place left for it to go since the hours took up the top spot. And now you can see on bottom I have minutes is the only unit left on bottom. And that's what I want on bottom, right? I wanted minutes on bottom. So we're good there. So now all I have to do is change these miles into feet. And so we need to know a relationship between miles and feet. So hopefully you know that 1 mile is equal to 5,280 feet. Okay? So once again, we have a choice to make. I can put my 1 mile in one spot and the 5,280 feet have to go in the other. But the question is, which one goes where? Well, I'm looking at my miles, right? I already have miles on top. So that means that these miles need to go on bottom. Therefore, my feet need to go on top. And now, since there's a miles on top and a miles on bottom, they will cancel out. And if you look, the only unit, there's no unit here, there's no unit here, there's only feet. And that's what I want. I wanted feet on top. So since I only have feet on top and I only have minutes on bottom, I have what I want. So now I just have to do some multiplication. So I'm going to multiply everything on top together. So 65 times 1, and then also times 5,280. So this is what I'm putting into my calculator, is 65 times 1 times 5,280. And this is what I get, 343,200. And that's going to be in feet. I'm keeping my feet because it's what I have. So 343,200 feet. Then on bottom, I'm going to multiply everything together. So 1 times 60 times 1. So I'm going to put that into my calculator. 1 times 60 times 1. And that just gives me 60. And it is in minutes. Minutes. And now all I have to do is divide. I'm going to take that top number, 343,200, and I'm going to divide it by 60. And I get 5,720. So 5,720. And we had feet on top per minute. So 5,720 feet per minute. All right, go to 19, right? 19 is fairly similar. Number 19 says this. It says that we have $6 per hour, right? That's what we're starting with, our $6 per hour. And I'm going to move this down, $6 per hour. And it wants us to change into cents per minute. Okay, so I have to change two things here. I have to change my dollars into cents and my hours into minutes. And once again, you can pick which one you want to change first. Either way is fine. But I'm going to change my time first. So I know that 1 hour is equal to 60 minutes. And you can see I have my, this is a 1 hour, right? That's a 1 hour on bottom. And so since hours are on bottom, when I put this new thing in, I want to put hours on top so that my hours will cancel. So if my hour went on top, that means my 60 minutes have to go on bottom. And now I have minutes on bottom, and that's what I want. I want minutes on bottom. So now the only thing I have to change is the $6 into cents. Well, hopefully you know the relationship. 100 cents, right? 100 pennies, which are worth 1 cent apiece, are equal to $1, right? So 100 cents is equal to $1. So since this dollar right here is on top, I'm going to put my new one on bottom, $1. So my 100 cents goes on top, and my dollars will cancel. There will be no more dollar signs. We'll just have cents. And if you're a keen observer, cents is exactly what we want. It's what we want on top. So we have cents on top and minutes on bottom. So we're exactly where we want to be. So now I'm just going to multiply. 6 times 1 times the 100. So 6 times 1 times 100 gives us 600. And on top we have cents is the unit there. And then on bottom we have 1 times 60 times 1. So 1 times 60 times 1 makes 60. And then this is in minutes, right? Okay? And now all we need to do is actually divide those. So I'm going to take 600 and I'm going to divide it by 60. And 600 divided by 60 is 10, right? And we had cents on top and minutes on bottom. So someone who is making $6 an hour would be equivalent to getting 10 cents every minute, right? 10 cents for every minute that they work. Okay? Look down at number 20, right? Number 20 is kind of in a funny spot. It moved to the bottom left there on you, but go ahead and look at number 20. And it says this, 3 over 6 is equal to negative 28 over x. This is number 20. And so this is a proportion problem, right? And since we have two fractions that are equal to one another, we can actually cross multiply here. So all I'm going to do is cross multiply. So x times 3 makes 3x. And 6 times our negative 28 is going to give us negative 168. Okay, and it's okay to use a calculator for that one if you need to. And so now to solve this problem, I just need to divide by 3 on both sides, right? X is being multiplied by 3, so to get it alone, I'm just going to divide by 3 on both sides. And so negative 168 divided by a positive 3, it's going to make a negative 56. So that's a nice, simple little proportion problem, right? All right, let's look at number 21. Number 21 gets a little more complicated. It says that x plus 7 over 2 is equal to 4 over 19. I have two fractions that are equal to one another, so I can cross multiply. But with this first one, now when I do the 19 times x plus 7, I'm going to go ahead and write it out like this to make sure that we remember that whenever you multiply by that 19, you actually have to distribute it. You have to multiply that 19 times the entire other side. So it's 19 times x plus 7, right? And then the other one's simple. 2 times 4 is 8, right? Now, if I'm going to solve this equation, remember I'm just trying to get x by itself, but in order to do that, I'm actually going to go ahead and multiply by 19. I got to distribute it. So 19 times x makes 19x plus, and 19 times 7 gives us 133. That's going to be equal to 8. Right? Now that I've done my cross multiplication, this is like any other equation, so that equal sign is splitting things up. So to get this x by itself, the first thing I have to move is the 133 over here. So since it's a positive 133, then what I'm going to do is I'm going to come back and I'm going to subtract 133 from both sides. So on this left side, the positive 133 and the negative 133 cancel, which means that 19x is equal to, and on the right-hand side, 8 minus 133 is going to give us 125. And so now my last step in order to get x by itself is just to divide by the 19, right? They were multiplying by it, and so we're going to divide by it. So you take that 125. Oh, and let me be careful here. I almost made a mistake, right? This is 8 minus 133. So this 125 should be negative, right? So that's a negative 125 on top there. So make sure you change that in your notes, right? Negative 125 divided by 19. And that's not going to go evenly, right? If you look in your calculator, you can plug it into your calculator if you want to, and you can see you're going to get some big, long decimal answer. So one of the best things you can do if you want to is you can just leave it. Negative 125 divided by 19. You can just leave your answer in that fraction form, and there's absolutely nothing wrong with that. It's actually the best thing to do. Okay, go ahead and flip over now, and we'll look at number 22. It says w plus 14 divided by 4w plus 6 is equal to 3 over 4. So now I still have two fractions that are equal to one another. So one fraction equal another one. So I'm going to cross multiply again. But this is actually going to require the distributive property twice. I'm going to have to do 4 times the w plus 14 as one of them. And then for the other one, I have 3 times 4w plus 6. And so I have to make sure I distribute on both of those, making sure I multiply by the entire thing on both sides. So I'm going to distribute my 4 here, and 4 times w makes 4w. And 4 times the 14 is going to make 56. You can use your calculator for that one. You will get a calculator on the test, so you can use the calculator to figure that one out if you need to. Then on the other side, we have 3 that we have to distribute. So 3 times 4w makes 12w. And 3 times 6, 3 times the 6 is going to give us 18. And so now this has actually turned into some problems that we worked previously on this study guide, right? We have variables on both sides of the equation that are separated by that equal sign. And so what we need to do is we actually need to get them together on one side, right? We need to combine them. So I'm going to move, we can choose to move whichever of these we want to. And I'm going to choose to move the 12 over here first. I'm going to move the 12. So since it's positive, what I'm going to have to do to get rid of it is subtract by 12 on both sides. So 4w. And I'm going to put the minus 12w. This is what I'm adding it in, but I'm going to put it behind this 4, remember, because they're like terms. And I just want to keep my like terms together. So minus 12w. So this is new. The minus 12w's are new on both sides. And notice I put them behind my other values that have w in them so I can combine like terms. So on this left-hand side, right, 4w minus 12w, well, 4 minus 12 is negative 8w plus 56. And then on the right side, the positive 12w and the negative 12w cancel, and we just get left with 18. Right? It's positive 18, but I don't have to write the plus sign anymore because there's nothing to be adding to. So we just put the 18. Now, I need to get w by itself, so the first thing I got to move is the 56, and since it's positive, I'm going to subtract it. So negative 8w plus 56 is what we already had, but now I'm going to get rid of it by subtracting 56. And I'm going to do it on both sides of the equal sign. So that on the left-hand side, the positive 56 and the negative 56 cancel, and I end up with negative 8w is equal to, and then 18 minus 56 on the left is going to give us negative 38. Now I'm going to divide by negative 8 on both sides in order to get w. They were multiplying by negative 8, so I'm dividing by negative 8 so that they will cancel. And that means that w is equal to, and then over here, a negative divided by a negative gives me a positive. Okay? And if you put that one into your calculator, you'll notice that it doesn't go evenly, right? You get a decimal. So we can leave it as 38 over 8. But this fraction right here is one that can be reduced, right? There's a number that I can divide both 38 and 8 by. Okay? So what I'm going to do now is I'm actually going to look and I'm going to say both of those can be divided by 2. So I'm going to divide the top number by 2. And if I do that, if I do 38 divided by 2, it gives me 19. And then I'm going to do 8 divided by 2 for the bottom number. And 8 divided by 2 gives me 4. So now that I've divided the top and the bottom by 2, I get 19 over 4. And that is the reduced fraction for the answer. So 19 over 4. And it's okay if you leave the answer as 38 over 8. They're the same value. The only thing is that 19 over 4 is the reduced version. Okay, 19 over 4 is reduced. Okay, let's look at number 23. 23 says this. It says, we're using the same directions for 23 and 24, but it says, the pair of figures is similar. Find x, round to the nearest tenth if necessary. So we have 2 rectangles, right? We have 2 rectangles. One big rectangle, one big one, and one small one. But they're similar figures. This one says 11 and 9. This one says x and 5, and we want to solve for x. So remember, we're looking for a match. And so what I'm going to observe is that is in this left rectangle right here, in the big one, I know both sides, right? So I'm going to make a ratio out of those sides, which means I'm just going to turn them into a fraction, 11 over 9. And I could put 9 over 11. The order you put them on in the fraction doesn't really matter. You just need to keep up with them. So I'm going to call this, this 11 over here, I'm going to call it left because it's on the left side. Left. And this 9 I'm going to call down because it's down on this rectangle. So down. And you can pick any names you want to for them, but we're only naming them so that we can make sure we get our other rectangle in the right spot. So when I get ready to find x for this other rectangle, what I'm going to do is, since the 5 is in the same spot as the 9, they were both down, I want to keep them in the same spot in the fraction. So the 9 is on the bottom of the fraction. So that means this 5, which was down, should go on bottom of the fraction. And the same thing with the others. This 11 was on the left, and so is the x. So since the 11 and the left is on the top, I'm going to put the x on top. So now I can rewrite it without all of the other stuff. It's just 11 over 9 is equal to x over 5. And that's the proportion that I'm trying to solve. And I'm just using those labels to help me set it up. So I'm going to cross multiply. And 5 times 11 makes 55. And 9 times x makes 9x. So I'm going to divide by 9 on both sides so that I can get my x by itself. And I get 55 over 9 is equal to x. Now, I've told you before that it's okay to leave those. You don't have to turn them into decimals. The only difference is that in this problem, if you read the instructions very carefully, the bold up above it, it says round to the nearest tenth if necessary. So since they tell me to round to the nearest tenth, that's a decimal form. So I can't leave it as a fraction if they want me to turn it into a decimal. So I'm actually going to take the 55 and divide by 9, and this is what it gives me. It gives me 6.1111, and those ones just keep going. But it said round to the nearest tenth, and hopefully you know that the tenths place is the one right after the decimal. So that's the last number that I actually want to be part of my answer. So I'm looking at the one right next to it, and it's a 1, so I leave it the way it is. This is 6.1 is equal to x, is the final answer that we want. 6.1 equals x. Okay, let's go to 24. '24 has a couple of triangles, right? So I'm going to use some triangles here. See if I can get them to... Mine are going to be facing a different direction. I can flip them though, so let me flip these right quick. Okay, and then this is what it says in the picture. And in the picture, the small one's on the left side, right? So this is 21 and x, and 34 and 14. Now, once again, I'm looking for a match. So This big triangle right here is the one I want because I know both sides in it. That gives me a match, right? It gives me a pair that I can actually put together. And hopefully you remember I'm just going to put them together in a fraction. So 34 over 14. And I could put the 14 over 34. It's not a big deal which order you put them in, but remember you just need to name them. So this 34 I'm going to name up because it's above the 14. For the 14 I'm going to name down. And you can name them anything you want to. We just have to make sure we get everything in the right spot. Because now when I look at my small fraction, the thing that I'm paying attention to is that this 34 and this 21 are in the same spot. They're both up. So since the 34 up is on top in this side, then what I'm going to do is on the other side of the fraction, I'm going to put the 21 on the top because it was an up. And since the 14 or the down is on bottom in this triangle, then what I'm going to do is on the other side, I'm going to put this x on bottom because it was in the same spot that the 14 was. So 34 over 14 is equal to 21 over x. And now this is just a nice, simple ratio problem. Excuse me. So I'm going to cross multiply, and x times 34 makes 34x. And then 14 times 21 on the other side. So 14 times 21 makes 294. And now to get x by itself, they're multiplying by 34. So I simply need to divide by 34. So these cancel, and x is equal to, if you take calculator and do 294 divided by 34, it gives me 8.647. And remember, the only reason that I'm not leaving this one as a fraction again is because the directions on this one told me to round to the nearest tenth. So I'm going to round to the nearest tenth. That is a decimal. So here's my tenths place. So I'm going to look next to it, and there's a 4. So I round down, so this thing just stays at 8.6. All right, let's go to number 25. 25. It says this. It says 2 rectangles are similar. One has a length of 10 centimeters and a width of 8 centimeters. And the other has a width of 7 centimeters. Find the length of the second rectangle. Round to the nearest tenth if necessary. Okay? So one has a length of 10 and a width of 8. Remember, I'm looking for a match. I'm looking for something where I know both pieces of information. And so that first rectangle is the one that I'm looking for because it tells me both the length and the width for that one. But if you notice, if you keep reading, and the other has a width of 7. So for that last one, I only know the width. But in the first one, I know the length and the width. So I'm going to make a fraction. 10 over 8, right? And the 10 was the length, so I'm going to call it L. And the 8 was the width, so I'm going to call it W. I'm going to use that match to make a fraction, to make a ratio. And then I'm going to come back and look at what I have on the other side. It says, and the other one, so this is the other one, has a width of 7. So this other one that they're going to tell me about is a width. I know the width of this other one is 7. So since my width in the first one is on bottom, the 8W is on bottom, then when I put in this 7, I need to put it on bottom as well so that both of my widths are in the same spot. And then the question here is, what is the length? What is the length? Find the length of the second rectangle. So I'm going to put my x up here at the top because I'm looking for the length. I don't know what it is, but I'm searching for it, so I'm going to put it up at the top. So 10 over 8 is equal to x over 7. And I'm going to cross multiply. 7 times 10 is 70, and 8 times x is 8x. Now I'm going to divide by 8 on both sides to get my x by itself. So I have 70 divided by 8, and that gives me x equals 8.75. And again, I'm not changing this. I'm not leaving this one as a fraction, okay? If you wanted to, in any other circumstance, leave this as 70 over 8. You know, you could divide by 2 in both spots and get 35 over 4 and leave it as a fraction. That will be perfectly fine. The only difference is now the directions actually tell me to round to the nearest tenth. So that's talking about a decimal. So here's my tenths place. So I'm looking next to it, and it's a 5, so I round up. So I'm going to call this 8.8. So my final answer is going to be 8.8 when I round to the nearest tenth like it told me to. Okay, so the next one actually gives us another word problem, but it also helps us with a little picture. It says a tree casts a shadow 10 feet long. A boy standing next to the tree casts a shadow 2.5 feet long. The triangle shown for the tree and its shadow is similar to the triangle shown for the boy and his shadow. If the boy is 6 feet tall, how tall is the tree? Okay? And then they have a picture, right? And mine's not going to be nearly as good as theirs. But here's a boy, and he has a shadow. Okay? And they told us that the shadow is 2.5, and so you can see the 2.5 on the picture. And then there's the tree. Right? There's a tree. And we're told that the tree casts a shadow that's 10 feet long. Okay, so the tree casts a shadow that's 10 feet long. There it is. A boy standing next to the tree casts a shadow of 2.5 feet. There it is. The triangle shown for the boy and his shadow and they're similar to the triangle shown for the tree and its shadow. If the boy is 6 feet tall, how tall is the tree? Oh, well, there's some information that they left out. The boy is 6 feet tall, right? 6 feet tall. So now when I know the boy is 6 feet tall, this is a match. I have 6 over 2.5. Now 2.5 is the shadow, and 6 is how tall they are. So I'm just going to call it T. So 2.5 is for the shadow, and 6 is T. So when I look at the other side, I want to make a fraction, and the 2.5 is the shadow on bottom, and the 10 is the shadow. So I'm going to put the 10 on bottom. I'm going to put it in the same place that the 2.5 was. The 2.5 was on bottom for a shadow. So the 10 is going to be on bottom for a shadow. And then the question is, how tall is the tree, right? How tall is the tree? So I'm going to do my same thing. I'm going to cross multiply here in order to solve this. And 10 times 6 makes 60. And 2.5 times x makes 2.5x. And once again, to get my variable by itself, I just need to divide by 2.5 on both sides of the equal sign. So 60 divided by 2.5 gives us 24 is equal to x. So the tree must be 24 feet tall, right? So that's it for Study Guide B. I hope that it was helpful, and I hope that you are ready for your test on Friday. So good luck.